This is RD Sharma solution we are taking, and this is the class 12th probability. Exercise is fifth exercise. Three persons A, B, C throw a die in succession. Now this question you need to understand very well because the 35th question is exactly like this. So three persons, they throw a die in succession till one gets a 6 and wins the game. There is a die. Three people throw in succession. So 1 to 6 can come for the first one, followed by 1 to 6 can come for the second one, and 1 to 6 can appear for the third one. Whoever gets 6. So how many possibilities are there? 6 is only 1 in 1 to 6, and in all possibilities 6. So 1 by 6 is the probability of getting a 6. So you can just call it as probability of getting a 6, which is true for all of them, A, B, C. So probability of getting a 6 is 1 by 6. And probability of not getting a 6, that is 1, 2, 3, 4, 5 appears. This is simply 1 minus 1 by 6. So this is going to be 5 by 6. And this is what we are going to use a lot in this question. So please understand these two probabilities. Now, geometric progression is the key here, which we are going to use a lot. 1 plus a square plus a cube, this goes on and on to infinity. Now, if you take any two consecutive numbers and you divide them, the ratio remains constant and for the entire series. So this is 1 by 1 minus a. A is the common ratio. This is the summation or sum of the series that which we are going to use just now. So let's call these three as A, B, C. Now what is the probability of A winning? Then what will be the probability of B winning? And third is the probability of C winning. Now I want to show you all of them together so that you understand the commonality and the differences between the approach. Now what happens? A starts. So A can win at the first go. He is lucky, fortunate enough. Then if A wants to win, A has to lose, B has to lose, then C has to lose, and then A comes. Means the option of A comes, then A will win. Or A fails, B fails, C fails. Then again A fails, B fails, C fails. Now the chance of A winning comes and he wins. So these are the different possibilities of A winning. Now when B has to win, so B chance comes only after A. A losses, B wins. A losses, B losses, C losses, A losses, then the chance of B winning comes. Or A loses, B loses, C loses. A loses, B loses, C loses. A loses, then B's option will come and he may win. Now for C, A and B has to fail. The second option is A, B, C, A, B, they have to lose. Then C comes. The third option here is, and this is not the third and the last option, this goes on and on forever. So A, B, C lose, then again A, B, C lose, then A, B lose, then C comes. So this is the approach or the logic of this question, that when A wins, when B wins, and when say C wins. So we just call it as a probability of A plus probability of A bar intersection, B bar intersection, C bar intersection, and A intersection. And this all goes A, B, C, A, B, C bar intersection with A. And this goes till infinity. Now what is the probability of B winning? With the same analogy, this A bar intersection B, the probability of A bar, B bar, C bar, A bar, and then B comes. Then the probability of A, B, C, A, B, C, A, they all lose, then B comes. And in this, the losing, B is also inclusive because B has to win, so he has to lose some time. Then here for C comes after A and B, so A and B have to lose. Then C again comes after AB, so ABC loses, AB loses, then C comes, or C chances of winning comes here. Or ABC, ABC, AB should lose, then only C. That means wherever C chances come, then only the option of winning and losing will appear. Sometimes he loses, sometimes he wins. So probability of A, probability of B, and probability of C all together winning is 1 by 6. And probability of A losing, probability of B of loss, or probability of C not getting through is 5 by 6. So wherever in this question you see a bar, write 5 by 6. wherever you see a normal probability, whether it be A, B, C, it's 1 by 6. So I'm just replacing these values. These are independent events, so I'm just writing one of them so that you understand that this PA bar, B bar, C bar intersection with A gives you PA bar multiplied by PB bar multiplied by PC bar multiplied by PA. So plus, PA bar is 5 by 6. All bars are 5 by 6 in this question. So 5 by 6 3 times here, 5 by 6, 5 by 6, 5 by 6, 3 times, and then comes PA, which is 1 by 6. Now don't worry about the upcoming terms because we are going to get the result by 1 or 2 only. We need 1 at the first and A at the second. That's what a geometric progression demands for us. Now here PA bar multiplied by PB for the first one. So 5 by 6 multiplied by 1 by 6. This is the first term. The second term is A bar, B bar, C bar, A bar. So 5 by 6 4 times followed by a B. The 4 times 5 by 6 we are going to multiply, followed by a B, which is 1 by 6. Let me reiterate, wherever A, B, C comes, 1 by 6. Wherever A bar, B bar, C bar comes, it's 5 by 6. That's what you have to do. I'm not writing the third one, the third option, because the first and second options are more than enough to constitute a geometric progression or geometric series. Now here also, A bar, B bar, C bar, so 5 by 6 into 1 by 6 in the first term, and this is how it goes on for the second one. All bars are 5 by 6, all normal without bars are 1 by 6. Now I'm going to show you that all these are having a common content. How? When you take 1 by 6 common from the first series, that is PA wins, 5 by 6 cube remains inside. And with our previous knowledge, this second one or third one rather will be 5 by 6 raised power 6. This goes on and on. Then the second one, this 1 by 6 and 5 by 6, take both of them. 5 by 6 and 1 by 6 gives 5 by 36. Inside this we have 1 plus 5 by 6 whole cube. You have already taken 5 by 6 and 1 by 6 out. So 5 by 6 to the power 3 will remain. All the 3 terms, all the 3 series, the second term remains the same. Only the coefficient or the value which is preceding this series are changing. Now I'm taking 5 by 6, 5 by 6 and 1 by 6 outside. This gives you 5 5 is 25 divided by 2 and 6 outside. Inside one will be 1 plus 5 by 6 whole cube plus 5 by 6 whole raised to the power 6 again. Now this all, let's compute this one. So 1 by 6 multiplied by the result of the series, 5 by 36 multiply the result of the series, and 25 divided by 216 multiplied by the result of the series is going to eventually come. Now coming to the geometric progression, because we have got the geometric progression series, which is 1 plus 1 5 by 6 whole cube plus 5 by 6 raised 6. If you divide any of these two, let me show you, it is going to come as 5 by 6 raised 3. So you have 5 by 6 raised 6 divided by 5 by 6 raised 3. This will give you 5 by 6 raised 3. So this is 5 by 6 raised 3. 5 5 is 25. 25 into 5 is 125. 6 into 6, 36. 36 into 6 is 216. So you have 1 by 1 minus 125 divided by 216. So I'm writing it here just to let you know. I know that this is quite easy for you, but 216 goes up. 216 minus 125. So this gives you 91. So now multiply 1 by 6 with 216 divided by 91. Multiply 5 by 36 by 216 divided by 91. Multiply 25 by 216 by 216 multiplies by 91. So these are the probabilities of A winning, B winning and C winning respectively. Let me write the final values now in order to conclude this solution. The first one is going to be 36. This goes 636 divided by 91. The second one 30 by 91. The third one is 25 by 91. Now this is how the steps you are going to witness in this reference, and if you are doing it by yourself, write all these. Never let these escape from your writing. A and B take turns in throwing 2 dice. The first to throw 10 being awarded the prize. So whoever gets a 10 gets a prize. Show that A has the first throw, so it's established that A is going to start. The chance of winning are in the ratio 12:11. Now we are going to do this question in a different way. If you remember, we have already completed a question with 9:8 ratio. But here this set of getting a 10. So when you throw a die, the die, whatever number appears, if you add them, it has to come as a 10. So 5, 5, 6, 4 and 4, 6 are the possibilities, because when we add these values, you are going to get a 10. So what is the probability of getting a 10? It's favorable cases, which are 3 in this case, and total number of cases are 36 when you throw a die. So 3 divided by 36, which gives you 1 by 12. Now probability of not getting a 10, and this is going to be 1 minus 1 by 12, and that is going to be 11 by 12. Now A starts followed by B. So A will also win, B will also win, and what are the chances of them winning? The ratio of their chances of winning is 12 by 11. So probability of A wins. Now A will win at the first go. He throws, he gets a 10. Any of this, 5, 5, 6, 4, or 4, 6. Or if A doesn't get a 10, B has to fail so that A wins. Then A fails, B fails, A again fails, then B has to fail so that A could win. This is nothing but probability of A plus probability of A bar intersection B bar intersection A plus probability of A bar intersection B bar intersection A bar intersection B bar intersection A. So all these goes in intersection because these are an event, a separate event. All these three are separate events, and these events are internally independent of each other. So let's call this PA and PB together as 1 by 12, because both are going to get 10 in order to win. PA bar and PB bar is equal to what, 11 by 12, both of them, because these are the chances of they not getting a 10. So PA, wherever you get A and B, write 1 by 12. PA bar, let me write it like this just to let you know what I am trying to do. PA bar multiplied by PB bar multiplied by PA. So wherever you have a bar, write 11 by 12. Bar is 11 by 12. You get a PA, just replace it by 1 by 12. Now this you can write, you can skip it, because we are already going to get a GP from two numbers or two terms. So if you take 1 by 12 outside, 1 plus 11 by 12 whole square, 11 by 12 raised power 4, 11 by 12 raised 6, 11 by 12 raised 8, will go on and on and on. GP series addition is 1 by 1 minus A. I already explained it to you in the earlier questions. So this 11 by 12, if you take any two terms, 11 by 12 raised 4 by 11 by 12 raised 2, the common ratio is 11 by 12 raised 2. That is nothing but 121 by 144. So 1 by 1 minus this will be 121 divided by 144. So 144 goes up. 144 minus 121 is 23. This is 1 by 12 multiplied by 144 divided by 23. So this is 12 by 23, because 12 times 12 is 144. Now PA wins is 12 by 23. What is the probability of B winning? You can apply the same scenario here also. But rather than doing this, let's find a different approach. If A wins, B doesn't win. If B wins, A will not win. So in order to get the probability of B winning, why not to subtract the probability of A winning by 1? So 1 minus probability of A winning gives you the probability of B winning. So 1 minus 12 by 23 is actually the probability of B winning. So this is 11 by 23. So probability of A win divided by probability of B win, which is what is sought in the question, we have to prove it. So PA by PB is nothing but 12 by 23 divided by 11 by 23, and this goes 12 by 11. This is your final result. So this is the formal way of doing it. If you want to write, this is the way you need to go ahead. There are 3 red and 5 black balls in bag A, 2 red and 3 black balls in bag B. 1 ball is drawn from bag A, 2 from bag B. Find the probability that out of 3 balls being drawn, 1 is red and 2 are black. So these questions we have done already in the previous few questions, and 1 or 2 questions are coming after this also. So I hope that this reference will help you. Fatima and John appear in an interview for 2 vacancies for the same post. The probability of Fatima's selection is 1 by 7 and that of John's selection is 1 by 5. What is the probability that both of them will be selected? Only one of them will be selected. None of them will be selected. So the probability of Fatima, let's call it PF or PA, it's 1 by 7. Probability of J wins, let's call it PJ or PB, it's 1 by 5. So probability of Fatima not making to the interview, it's making means not getting successful, is 1 minus 1 by 7, which is 6 by 7. Probability of John failing in the interview is 1 minus 1 by 5, which goes 4 by 5. We are going to employ this in this question. Both of them getting selected, that is A and B, F and J, both are getting selected. I am representing F by A, J by B. This is going to be PA multiplied by PB because these are two separate events. 1 by 7 into 1 by 5, this gives you 1 by 35. Coming to the second one, only one of them will be selected. So A selected, B doesn't, or B gets selected, A doesn't make it. So just intersect them, take the probability, add them. This is nothing but PA multiplied by PB bar or PB complement plus PB multiplied by PA bar or PA complement. All these values are known to us. PA is 1 by 7, PB is 1 by 5, PA bar is 6 by 7, PB bar is 4 by 5. So this is A and B, F, A, J is B. So 1 by 7, 6 by 7 for PA and PA bar. PB is 1 by 5, PB bar is 4 by 5. So just multiply these and add them. So this is going to be 2 by 7. The third one. Now these are A and B. As I told you, this is A bar and B bar. I am replacing it just to get the clear picture because none of them will be selected only when they both have the complement intersected. So neither A nor B, neither Fatima nor John. So F bar, J bar represents A bar, B bar. Probability of A bar intersection B bar is PA bar multiplied by PB bar, and these are already being computed. This goes 6 by 7 into 4 by 5. So when you multiply these two, you're going to get 6 4 is 24 divided by 7 5 is 35, and this is your final result. So this is how you're going to go about it. These questions have been done earlier also. I hope you have a clear picture. This question we'll take in the next discussion. Till then, thank you so much. Have a good one.